Next on our list, Neurophos received some funding. And Bob, I recalled that when you were at Microprocessor Report, you covered some of the optical processing startups. So what are your thoughts about this company, Neurophos?
Yeah, I've been, covering the so-called photonic computing space. I think I wrote that article back in 2019, so it's been quite a while. And I mean, I would say that Neurophos represents kind of a second generation of photonic computing startups. Most of the early folks either gave up or pivoted to something else. I think out of the companies I wrote about back then, Light Matter and Light Intelligence both pivoted to photonic interconnects because they saw greater value in interconnects than in the computing side, although Light Matter did publish a paper, I think, last year on photonic computing. So apparently they're still dabbling there, but that's not really the focus of the company. Luminous, I think, is now out of business. They were Princeton spinoff. And so now there seems to be another generation. There's Neurophos. There's also a company called Quant, spelled Q.ANT, based in Germany. Some of these have been more oriented towards vision processing, particularly ones that use optical convolution. And so, there's some very specific vision processing applications that fit well. But in terms of what we normally think of as AI and more in the context of large language models and what's going on in the XPU world, the challenge has been twofold. One is that even though the actual compute is sort of zero power, which is nice to be able to push the zero power compute, the problem is you still have to get data in and out, right? And so you end up being constrained by both the ADC and DAC going kind of digital to analog, or however you're doing that digital to analog conversion to get in and out of the photonic space, and then also and just the data movement, getting data in and out of the photonics, but then also the scaling, because the photonic elements are really large, right, relative to transistors. And so one of the challenges has been, okay, yeah, you can build a 64 by 64 matrix, but then how do you scale?
Yeah, right. It doesn't really, 64 by 64 doesn't really move the needle in terms of total throughput at any speed. And, if that's going to occupy the same footprint as, your XPU, then it's like, what are you really gaining?
Exactly. So, I mean, it appears that Neurophos is targeting much larger scale systems, and they haven't disclosed a lot of detail yet. But I mean, the way to go about that is to have multiple silicon photonic chips or PICs connected using photonics so that you're not going in and out of the digital domain, right, or in and out of the electrical domain. So if in fact that's what they're doing, which is scaling across multiple PICs using photonics, then that would be sort of the first time we've seen a scalable photonic computing architecture. Although, light matter could theoretically do something similar. As I said, they're really investing on the interconnect side and this whole kind of photonic interposer concept. So it's interesting. I think they're probably the only, startup I've seen really targeting the more modern AI models rather than kind of the computer vision space.
Right. Yeah, so from what I've seen, so first of all, they have a mock-up of a server tray, and it's a little hard to see where some of the interconnects are. You could see like a little optical pigtail going out to the edge. I'll put that on the screen. And they've talked about saving space by essentially doing geometrically folding using mirrors or prisms to do one stage and then go over to another stage and then come back versus doing everything linearly. So there's kind of some space savings there, trading like linear space for 3D volume. The other thing I noticed about them is they're really focusing on the MAC array, creating a large systolic array. And the argument is if you're feeding a systolic array from the edges, your edge size grows at a slower rate than the array size, which is going to grow geometrically. So if you can make your optical component small enough, there's an advantage to just sort of like you get some area advantages the bigger you can make the array, because the ADC interfaces on the edge are, those are linear things versus aerial things like the computer array.
Yeah, I mean, the only way to make this work is to amortize the power cost of ADCs and DACs across many compute operations, right?
Yeah.
Yeah, so clearly you have to have this kind of multi-photonic chip scaling in the architecture to make this a really viable technology.
Right. And then I still have the concern that a lot of the AI accelerators, NPUs, XPUs we have now, they're not really compute limited in a lot of cases. They're memory access limited. I mean, it's always good to speed up the computational rate, but the real gains might be in if they can do something to reduce the power so that, we're not continually growing the power footprint of each new generation of XPU to get to higher performance.
Yeah, I mean, I remember going back to microprocessor report, I think when we were looking at some of the different approaches to accelerators, the realization there was that, roughly half the power was just being spent on data movement, right? And so, as you say, compute becomes sort of not the limiting factor in performance scaling. Anyway, it'll be interesting to see. I think everybody that has tried thus far has either been in sort of a niche space, again, around more vision models or image processing, or, pivoted to something else to basically survive. So we'll see if, this sort of second generation can do something different and actually make this a viable technology.
Well, they've got $100 million at this point to keep them busy.
Yeah, these days that doesn't sound like a lot.
No, it doesn't. Not when we're talking about $100 billion investments in some of these AI companies. Hi, you've been watching a segment from a longer Byrne-Wheeler report discussion. To watch the preceding segment, please click up here. To watch the next one, please click over here. You can subscribe by clicking this round orb, and to see another video in our series, please click down here.